4, pages 143 to 147, the extreme value theorem. The next couple of videos will be focusing on various different theorems, and today's is about the extreme value theorem. In the previous unit, we investigated heavily how to locate relative extrema of a graph of a function by using the derivative. In the space below, we're going to distinguish between a relative and an absolute extrema. So, a relative extrema are points on the graph of a function where the function changes from increasing to decreasing, or vice versa. An absolute extrema are the highest and lowest points on the graph of a function. Within an interval. Okay, so relative extrema is when anywhere where the function is changing from increasing to decreasing or decreasing to increasing, whereas absolute extrema are the highest and lowest points on a graph of a function within an interval. So we have two graphs here, f of x and g of x, and we have a few questions that we need to answer. So first, for f of x, is we want to identify the coordinates of the relative extrema of f. So relative extrema, again, whenever the graph changes from increasing to decreasing, right? We're used to calling those the max and the mins, the relative max and mins. So here we go. We have relative max at -1, 3. And we have relative mins at -3, 0, and 2, -6. Okay. Similarly, for g of x, we're looking for max and mins. So we have a few going on here. So we have relative max at -1, 4, and relative mins at -3, -4, and 3, 2. Okay, so those are our relatives. So now our question is, on this domain of f, what are the coordinates of absolute extrema of f? So absolute means the highest point and the lowest point, right? So we have absolute max will be the highest point that this graph can go for f of x. Since this graph increases forever on the left and the right, the absolute max does not exist. Right, so there is no absolute max. Absolute min, the lowest point of our graph, is at the point 2, -6. Okay, and on G, we're looking at the domain of G. Notice that at the endpoints, they don't go on forever. So these endpoints are still coordinates on the domain of G. So the absolute maximum point is this point here, which is 6, 5. And our absolute min is this point here, which is -3, -4. Okay, so on the domain of the given function, did the absolute extrema occur at the function's relative extrema? So the absolute extrema could occur at the function's relative extrema. For example, the absolute min was at the relative min. However, this does not have to occur, right? Because the absolute max was not at the relative max, right? So the absolute extrema can occur at the relative extrema, but it doesn't necessarily have to. Okay, so let's look. Same graphs, but now we're going to look at them at different intervals. So on the interval from -2 to 3, so we're looking -2 to 3. What are the absolute extrema of f? So if I box in every part of the graph that is within this interval, I can see that the absolute maximum of this graph is at the point -1, 3. And the absolute minimum is at the point 2, -6 on that interval. Okay, so for g of x, we're looking at the interval from -4 to 5. And we're looking for the extrema on this interval. So again, if I box in every part of the graph on that interval, the absolute max occurs 2 places, here and here, which are -1, 4 and 5, 4. And our absolute min occurs at this point here, which is -3, negative. Okay. So now we're going to switch up the intervals a little bit. So now I want the interval from -4 to 1. So here's -4, here's 1. I'm going to box in part of my graph that exists on that interval. Okay, so then on that interval, the absolute max, the highest point here is in this corner, which is at -4, 5. And our absolute min occurs right about here, which is at the point 1, -3. And on this interval from -2 to 6, here's -2, here's 6. Again, gonna box in everything that exists on that interval. So the highest point here is in that top corner, so our absolute max occurs at 6, 5, and our absolute min occurs at -2, 0. Okay, so when the domain is restricted to a particular closed interval, at what 3 points could the absolute extrema exist? So absolute extrema could exist at 1, the endpoints of the interval, 2, the relative max or min. Actually, let's rewrite that so that we are more specific. Where f of x has horizontal tangent. I cannot spell. Or 3, where f of x, f prime of x is undefined. Okay, so relative absolute extrema could exist at the endpoints of the interval, where the function has horizontal tangents, or where f prime of x is undefined. So the extreme value theorem states that if f of x is continuous on the closed interval a, b, then f of x has at least one absolute max and at least one absolute min on the closed interval. Okay. So let's look at a problem together. So to the right, we have a graph f of x equals -x cubed minus 6x squared minus 9x plus 2. on the closed interval from -4 to 1. So we're going to use this graph to answer some questions. So we want to know what the absolute maximum of f is on this closed interval. So from -4 to 1, here's our graph in that box. The highest points of this graph are here and here. So we have -4, 6 and at -1, 6. The absolute minimum of this graph is way down in this corner, which is at, oops, I think I drew the line wrong. So -4, -1. So the absolute minimum of this graph is actually right here, which is at -3, 2. Now we're looking at the interval from -4 to 1, which is the whole graph. So our absolute maximums are still going to be -4, 6 and -1, 6, because those are still the highest points of our graph. However, now the lowest point of our graph is at 1, -14. So we want to use the extreme value theorem to locate the absolute extrema of this function on the given closed intervals. We're going to use our algebraic results to make sure that our graphical conclusions are correct. So on the interval from -4 to -1, we want to find the absolute max and the absolute min. So what we're going to do is we first have to figure out what the relative max and mins are on that interval. So we need to find the derivative of this function. It will be -3x squared minus 12x minus 9. We need to set that equal to 0 to find our critical values. Okay, we can factor out a -3 from all terms. And when we factor this, we get that 0 equals -3, x plus 3, x plus 1. So my x is equal to -3 and x is equal to -1. Okay. So as we know, absolute extrema can occur at the endpoints, which are -4 and -1. And at our horizontal tangents, which are -3 and -1. And since we don't have any points where the derivative would be undefined, we don't have to look for those values. So what we're going to do is we need to figure out what is the value of the function at these values of x. So we need the value of the function at -4, we need the value of the function at -3, and we need the value of the function at -1. So at -4, the function, the original function is equal to 6. At -3, the original function is equal to 2. And at -1, the original function is equal to 6. So our absolute extrema, right, so our absolute maximums, our highest value that the function can be is going to be at -4, 6 and -1, 6. And our absolute minimum The lowest value that our function can be will be at -3, 2, which matches what we did above. Okay, so what I want you to try now is figure out, using algebra, we've kind of already done all of the major work together, but I want you to figure out what the absolute max and min would be on the interval from -4 to 1, and check to see that it matches our graph. Okay, so for each of the following functions, we're going to state specifically why the extreme value theorem is or is not applicable on the given interval. So our interval is from -5 to 0. So h of x, just remembering that EVT is only applicable if the function is continuous on the interval. Okay, so first thing we want to make sure is that our function is continuous on the interval. So h of x has a point of discontinuity when the denominator is equal to 0. So when x plus 3 equals 0, we have a point of discontinuity. So x equals -3. -3 is on this interval. So EVT is not applicable for h of x because, no, for h of x on this interval. It could be applicable on any other interval. For h of x on the interval -5 to 0, because h of x is not continuous. At x equals -3, which is on the closed interval from -5 to 0. Okay, so now let's check g of x. Since this is a square root function, we know that we cannot take the square root of a negative number. So anytime that x minus 3 is negative, we're going to have a problem. So if I put x minus 3, it has to be greater than or equal to 0 in order for this to be defined. So x has to be greater than or equal to 3. And looking at our interval, x is only between -5 and 0, so therefore EVT is not applicable for g of x on the interval -5 to 0, because g of x is only continuous for x greater than or equal to 3. Okay, now for f of x, when we take ln, we cannot take ln of anything less than 0. So we can't take ln of a negative number. So x plus 7 has to be greater than 0. So x has to be greater than -7. So looking at our interval, x is going to be greater than -7. So EVT is applicable for f of x on the interval -5, 0, because f of x is continuous for all x greater than -7. Okay. So now we're going to do a few example problems. Given the functions below, we want to determine the absolute extreme of values of the function on the given interval, provided the extreme value theorem is applicable. If it is not, state specifically why it is not. So first thing we want to check is EVT going to be applicable to this function? Does this function have a point of discontinuity that we need to identify? F of x is a polynomial. Polynomials do not have points of discontinuity. So f of x is continuous for this value on any interval. So we're going to find the derivative. So f prime of x equal to 3x squared minus 4x minus 3. And we want to find the critical numbers. So we're going to set this equal to 0. And unfortunately, we can't factor this. So we're going to need to use the quadratic formula to figure this out, or we could just use a calculator. I'm rooting for a calculator. So x is going to be equal to negative 0.535 and 1.869. Okay, so now to check to make sure we're looking at all possible x values for absolute minimum for the absolute extrema, we need to find f of our endpoints, so -1 and f of 3. And we need to find f of the x values within our interval. So since both of these x values are within our interval, we need to find f of negative 0.535 and f of 1.869. So f of -1 is -2. F of 3 is -2. F of negative 0.535 is negative 1.165. Negative 1.121. And f of 1.869 is negative 8.065. So our absolute max occurs at our highest value. So if we look at all three of these numbers, the largest value is this one. So our absolute max occurs at negative 0.535, comma, negative 1.121. And our absolute min occurs at our lowest value, which is this one. So 1.869, comma, negative 8.065. Okay. All right. Since this problem is asking for the absolute extreme values, it's only asking for the y values. So our answers are our max occurs at y equals negative 1.121, and our min occurs at y equals negative 8.06. All right. So for number 2, I want you to try this on your own, remembering that all trig functions, well, sine and cosine functions are continuous on any interval. So you can apply the extreme value theorem to number 2. Now for number 3, we have the function x plus 2 to the 2/3 on the interval from -3 to 6. So if I were to rewrite this function, this is f of x and there goes my marker, is equal to the cubed root of x plus 2 squared. And since this is only taking the cubed root, that means that every x value can work, which means it's continuous on any interval. So EVT can be applied to this function. Okay, so what we need to do is we need to find the derivative of this function. So f prime is equal to 2/3 x plus 2 to the -1/3 chain rule times the derivative of the inner, which is 1. So f prime of x is equal to 2/3 cubed root of x plus 2. Okay, so what we need to find are the critical values, right? So critical values are when the derivative is equal to 0 or undefined. So since the numerator of this will never equal 0, f prime of x will never equal 0. However, the denominator can equal 0. And that occurs when x plus 2 equals 0. So f prime of x is undefined when 3 cubed root of x plus 2 equals 0, which occurs when x equals -2. So remembering that absolute extrema occur at endpoints, critical numbers, we need to now use that information to figure out what our absolute extrema are. So we need to find f of our endpoints, which are -3 and 6, and f of our critical points, which is just -2. Okay, so f of -3 is 1, f of 6 is 4, and f of -2 is 0. So our absolute max occurs at the point 6, 4, and our absolute min occurs at the point -2, 0. All right, so our absolute max occurs when y is equal to 4, and our absolute min occurs when y is equal to 0. Okay, so what I want you to do is number 4. Identify, can you use the extreme value theorem here? Is it applicable? And if it is, then find your absolute max and mins.